Alright guys, this week we're going to do the Diac and Triac Lab. With the beginning of your lab, you can see that eventually we're going to have an AC circuit going in, and we're going to have the Diac firing on the Triac. The symbols for these bad boys, there's the symbol for the Diac here. You can think of the Diac as two Zeners back to back. And for the Triac, you can think of the Triac as two SCRs back to back. So the Diac is kind of like a voltage sensitive switch. It's only going to turn on at a certain voltage. When it does turn on, it stays on. And then with the Triac is like two SCRs. So you need to put polarity to MT1 and MT2, and then it's waiting for a pulse going to the gate. And the pulse to the gate is usually the same polarity as MT2. Once it fires on, it stays on as well, as they're all thyristors. Okay. If you're looking at the actual Triac, then you can see that on the left-hand side, this guy is MT1. There's MT2. MT2 is normally connected into the heatsink. And then the gate is usually looking for a voltage the same as the MT2. So if you just had one of these small components and you were testing them out, you could put polarity to MT1 and MT2, and then just use this lead, and you could jumper out MT2 in the gate and see whether the Triac was working properly or not. With our units, they're a little bit harder to, well, not harder, but they're easier to work with, but harder to actually see the component. So inside of here, the lighting's a little bit poor today, but inside there we have the square with the three leads coming off of it, which you can't see with the lighting today. But you'll just have to take my word for it. With these guys, we have the three leads here. This guy here is MT1. This guy here is MT2. And here is our gate. Okay. The part number for these guys is the TIC206. That's a standard Triac. So if you look up the cut sheet on the net, you'll be able to find all the information on these guys. It's good for 400 volts. And you can pump 4 amps through this bad boy. Okay, so the next thing we're going to do is we're going to test out the actual unit here. So we're going to use the multimeter and test out the Triac and see whether it's working properly. What we need to do is we need to put the meter into the diode setting. So looking at the meter here, usually when you turn it on, it's in the DC setting, and we have to change it to the diode setting. So we're going to hit shift and then the diode, and now we're into the diode setting. The polarity here, I've used red for the positive and blue for the negative. So going back to the lab here, what we're going to do is we're going to use the multimeter, and we're going to put polarity to the Triac, and then we're going to see which pulse the gate needs. Usually the gate needs the same pulse as MT2. Okay, so first thing we're going to do is we're going to put positive to MT1, negative to MT2, and we're going to put the same polarity to the gate. So MT2 and the gate are both going to have a negative polarity. Okay, so let's take a look. First of all, what we've got is right now I've got the positive to MT1. I've got the negative to MT2, and I haven't connected up the jumper yet for the gate. So at this point, the meter's showing us that the Triac is not conducting it, which makes sense. It's like two SCRs back to back, and it's waiting for a pulse from the MT2 to the gate. So we're going to go to MT1 first, and you can see that it's still open. And here is MT2. And as soon as we do that, then we get the Triac conducting. Now this messes me up a little bit because I thought this guy was supposed to latch on, so I'll have to do a little bit more reading on this particular Triac. We can see that the gate here has the same polarity as MT2, which is the way that it's supposed to turn on, but I thought this guy was supposed to latch on, so I'll have to do a little bit more reading. If you guys find the cut sheet and find an answer for me, then post it in the comments. But here, in either one of these guys, we'll find that once the gate pulse is removed, then it opens up. So there's the pulse to the gate, allowing the Triac to conduct, and then removal of the gate polarity. Okay, next thing we need to do is we're going to reconnect the meter, and this time we're going to put negative to MT1, positive to MT2, and again we're going to have the same polarity to the gate. So MT2 is positive and the gate is positive as well. Give me 2 seconds to change those leads and we'll take a look at the meter. Okay, so what we've got is we've got MT1 negative, MT2 positive, and at this point we do not have anything connected into the gate. So again, it should be open. Yes, it's open. Still waiting for that pulse of current to go to the gate. Okay, let's take a look here. We've got MT1 here. If I put a jumper from the gate to MT1, we see nothing. It's still open. It's waiting for, again, that pulse to go to MT2. Okay, so at this point we have a positive voltage to MT2. We've got a positive voltage going to the gate, and that allows it to conduct. Again, messing with my mind here, I thought that this guy was supposed to latch. It's not latching for some reason. You can see that it's conducting when we get that pulse of current to the gate, but not latching. Okay. So again, it doesn't matter that these guys have, you can interchange the polarity here on MT1 and MT2, but the gate usually gets the same polarity as MT2 to fire this guy on. Okay, next thing we're going to do, guys, is we're going to put the Diac into the circuit. So with this lab, we're kind of moving all around here. The first thing we were doing was we're testing out the Triac, just to see if it worked. Next thing we're going to do is we're going to take a look at the Diac. So we're going to set up this circuit that we have on the board here. And we're going to take a look at the Diac and a 1 kilo ohm load resistor. Okay, so make sure that you have the right value for the load resistor. It's a 1 kilo ohm. And we're just going to set this guy up like this. We're going to have the AC coming in. So these are your terminals for the AC. They correspond to these guys right here. So we've got AC coming into the board here. Okay, on the positive and the negative. And then what we're going to do is we're going to put the Diac in there. And right across the source, we're going to have the Diac in line with a 1 kilo ohm resistor. So let's get that set up and we'll come back. All right, guys, so the first thing we got is the Diac in line with the load resistor, the 1 kilo ohm load resistor. And it looks like for the first part, we're going to look at the signal across the Diac. So we need the scope probe here, and we're going to put the ground clip here. You can interchange these. You'll get the same kind of thing, view on the screen. But for us, let's just keep the scope probe on the top, and we'll put the ground clip on the middle in between the Diac and our load resistor. So what we're going to do is we'll take a look here. We've got the Diac here. You can see that the symbol for the Diac is there. This one I'm using is the 33 volt 1 milliamp Diac. Okay, that is in line with the 1 kilo ohm load resistor. And right now, you guys showed me this trick last class. You can put one of these jumpers in here and jam the probe tip in there. And then if you're working alone, your partner isn't there that week, then you're able to take a look at the signal without having two hands to hold it in place. The ground clip right here is going to this part between the resistor and the Diac, and I'm going to leave my probe in place because if I touch it, it'll fall out, but I'm on the times 10 setting. Looking at the scope here, I'm on, let's see, 2 volts per division, and the time setting I'm on is 20 milliseconds. Again, make sure that, remember that other students, when they come in, they're going to start to screw around with all these buttons. Make sure that each of these guys is turned all the way. Otherwise, watch what happens to the screen here. If I change this value, all of a sudden it's going to change my waveform. You can see it's shrinking there. So make sure that this is turned all the way so you see the appropriate waveform on the screen. So this is the value that, or the waveform that's going across the Diac. So you can see here that the voltage is creeping up across the Diac. Then the Diac turns on right here, conducts that voltage towards the 1 kilo ohm load, and then turns off. It's always going to turn on at a higher voltage and turn off at a lower voltage here. And then again, it waits until the waveform increases in the opposite direction. It's a bidirectional kind of Zener diode. So it increases in voltage to the exact same voltage in the opposite direction. The diac turns on, conducts that voltage to the load, and then turns off, and then again waits for it to turn on again. So across the load, we'll see this small amount of voltage. Now, it's not going to be up here. That voltage will be dropped right down to here, because again, we're just going to see the difference between that point and the top of our waveform across our load resistor. Okay, so you can change the time setting here. Here you can see more of the sine waves coming through. I found that, what is this, at 20 milliseconds I was getting the best value here, kind of getting the full waveform here. Again, one more time, the voltage is increasing, the diac is turning on. That voltage is going towards the load, so that voltage is lost across the switch, which is the diode. The diac is, call it a diac, sorry. The voltage is increasing across the diac is turning on, the voltage is going towards the load, turning off here and increasing again in the opposite direction, and again the diac is turning on here, and this voltage right here we'll see across the load. Okay, so do your best to draw out that waveform. It's a little bit hard because it's pulsing in and out on the screen there. You can see here that it takes a little bit of while to see which way or what value that waveform is actually going to, but you'll find that it increases and decreases to about the same amount on both the positive and the negative portion of the waveform. Okay, try to get it so you have a full sine wave on the screen there, so you can see both the positive and the negative portion of the waveform. Next thing we're going to do, if we scroll down here, is we're going to look at the voltage across the resistor now. So we're going to use the scope. We're going to put the scope probe here now, and we're going to put the ground clip down here across our 1 kilo ohm load. So the remainder of that voltage, if we go back up to this screen, this small amount of voltage and this small amount of voltage, so we should see a little blip of voltage here, a little blip of voltage here across the load. So we need the diac in line with the resistor, so that's going to stay the same, but we're going to move our scope probe and our ground clip down. And if you take a look now, I've got the scope probe looking at the load resistor now. Again, I've got this so I can hold that in and keep looking at the screen there. And I've got this alligator clip going to the negative of the source now. So we said that that little blip of voltage, there we go, a little blip of voltage that was remaining from the diac there is going towards the load. So the diac is turning on here, allowing the remainder of that sine wave to go across the load. Then it turns off. Then the waveform increases, decreases across the diac, and the diac turns on, and this voltage is apparent across our load. Again, you can change around your time setting here, and you can see the pulses that come through. So the beauty of the diac is that you can use it as a pulse of current towards the triac and turn it on. And it provides both the positive and a negative pulse at the exact same time. Okay, so again, we've got the scope probe connected into the positive here. We've got the alligator clip connected into the negative. And we're going to draw out the exact same waveform that we see here on the screen on our lab. Okay, so this one's a little bit easier to try to draw out. So I'm on 20 milliseconds, 2 volts per division, and I'm on the times 10 setting. And again, that little blip of voltage that comes from the diac is right here, right? So that little blip of voltage comes through, the waveform increases, then the diac conducts, and we see this small amount of voltage going towards the load.